All right, good morning. So I work in Google in the security team. I get to look at a lot of the code that the JavaScript programmers or front-end engineers code at Google. They code small applications, medium applications, and complex applications. And it turns out, if you're writing a complex app, you end up having a lot of bugs, including security bugs, or as we call them, vulnerabilities. And one of those bugs in specific, well, bugged me, and I just wanted to fix it. And this is actually the topic of this talk. We came up with an API in the browsers that aims to eradicate or eliminate a certain vulnerability class that is pretty common for web applications. So it's called trusted types. Let's go on. Trusted types aims to eliminate a vulnerability called DOM-based XSS or DOM XSS or type 0 XSS. But is it even a problem for web applications nowadays? It turns out it is. So Google runs a program called Vulnerability Reward Program. We essentially pay people to report security bugs to us such that we can fix them and protect our users. And perhaps not surprisingly, web application bugs are the majority of the bugs that we get reported. At least half of them are web bugs or web platform bugs. And XSS is the most common out of those. But it's not just our data. Like other companies, other bug bounty programs, for example, report very similar issues. If you are writing a web application, it's very likely that you actually have a cross-site scripting bug. If you're writing a web application as a novice programmer or someone new to the team, you most likely have an XSS. That's almost a given. Right, this is data from HackerOne, a bug bounty company. And XSS, as you can see, is a top vulnerability here. This is data from Mozilla. Again, cross-site scripting is very prominent. It's a very prevalent vulnerability for web applications. And as you can see, this is a problem. But today I wanted to focus on one particular kind of cross-site scripting bug. Given that we are talking about JavaScript, it's the client-side vulnerability. So DOM-based XSS is a type of vulnerability that only occurs on the client in the web browser. It has nothing to do with how the server-side code works. And how does it look like? Well, essentially, it occurs when you're taking a user-controlled data, usually in a string, taking from a source that the user controls, like location object, for example, and later on you pass it to a dangerous function. We call those functions DOM syncs, right? Inner HTML is like this very basic examples. I'm pretty sure you are all aware that if you're just pushing user data into the inner HTML, it is possible that the data will turn into JavaScript execution and you have a cross-site scripting vulnerability, right? So that's the most basic examples. The problem is, it's not just inner HTML. It's over 60 other functions available in the DOM and similar APIs. So it's not just in HTML. Window open also shouldn't accept user-controlled data, source doc on iframes, all of that. And as you can imagine, it gets pretty untenable to protect your applications comprehensively against this kind of vulnerability, because you need to be aware every time what you are passing to those functions. And in practice, indeed, it is a problem. Right? We see that in Google data, in other applications, in other companies' data. And why is it the case? Well, those DOM syncs, those 60-something functions, depending on the browser version, can be called by your own code that you usually review or that applies to some kind of standards, maybe even code style standards. But that very same API, that very same functions are also accessible by all of your dependencies, the client-side dependencies, right? The ones that you, let's say, compile or bundle your applications with, but also the ones that you're actually including as a script node somewhere on your HTML code. And also, in turn, the scripts that are being loaded dynamically by those scripts. So it might be some widget from a third party. And each of those scripts, each of this code can potentially call these functions with user-controlled data, creating XSS. This is a problem. And this is actually where we see most of the vulnerabilities, in this perhaps not very reviewed parts of the code, right? And you can protect against it. You can try to mitigate this vulnerability. On client side, there's content security policy that unfortunately doesn't work particularly well for DOM-based XSS, but you can also try to protect it on, let's say, earlier when you're actually coding. So do some static analysis, for example. Unfortunately for JavaScript, as we all know, static analysis doesn't really work because JavaScript is a very dynamic language. And yeah, the data shows that in practice, DOM XSS is pretty prevalent as a vulnerability. It survives all our efforts, multi-year efforts to combat this. At Google, it is already the most common XSS variant, as I said. Thankfully, we do know how to address it. In general, in Google, we use the approach that is called safe types. It's an approach that we know that works. It does reduce the number of XSSs significantly by orders of magnitude, essentially. And we have multi-year evidence of efficacy of this solution. That's a solution that's mostly used for, let's say, server-side languages. We also have a JavaScript part of it. But it aims to address all kinds of XSSs. And today, I wanted to present you our solution that aims to make this solution more robust, but also accessible to JavaScript programmers out there. It will be built into the browsers. And this is called trusted types. Now, what is trusted types in essence? We try to make the DOM API strongly typed. And this sounds a little bit crazy or a little bit unusual, especially for JavaScript, where not a lot of APIs nowadays are typed, let's say. But we think it actually can solve the problem or address it very comprehensively. So the core idea is, as a JavaScript programmer, or when coding JavaScript, you stop using strings as the data values when they can be embedded into those dangerous functions, into the DOM things. Instead, you can use objects. Objects have this advantage that you can attach metadata essentially to them, right? String is a string. That's just a thing. But object can carry some information, especially the information that is useful for DOM XSS prevention, meaning where did the string come from? Was it sanitized? Should I trust it? Is it okay to embed it into those dangerous functions, or is it something that is there just by a mistake or something that's just an omission in my code? The DOM already supports it, right? So if you use an object that has a stringifier function, it will be just called implicitly by the browser, and the result of this function will be used instead. So this is this primitive that we are building upon. So what we are doing with this API, we have introduced 4 different types. The web platform just gives them, makes them available. They are called trusted HTML, trusted script, trusted URL, and trusted script URL. Trusted HTML is essentially a type that represents a value that is safe to include in something that we call an HTML context. So like, it usually contains an HTML snippet. So something that you would assign to, say, inner HTML. But there are also other things like that. So source doc, for example, on iframe. Trusted script is a piece of JavaScript, something that you would pass to eval or similar functions. Trusted URL is something that you would load a sub-resource from, so image source, this sort of thing. Trusted script URL is a URL that if you load it into your application, it will execute code. Most likely being, oh, that's interesting. Most likely being a script URL, right? So if you're loading additional JavaScript code, this will execute JavaScript in turn, right? And given that those are types, we can pretty easily build security rules and controls around them. We're not just working with strings that are dumb in this sense that you don't really know what the value represents. If you're using the types, we exactly know what to expect of the data. Now, how does it look like? So, if the trusted types are not enforced, we will get to that. We will get to how enforcing works a little bit later. The DOM strings accept strings as usual. Oh, there's actually a thing missing here. But essentially, if you're assigning to an inner HTML property of an element a string, it works as usual, right? That's what you would expect. But you can just as well assign to inner HTML a typed object. In this particular case, to inner HTML, you want an object that is a trusted HTML. We will get to how you actually create those objects a little bit later. When the web application author decides to use this API in an enforcing mode, then what needs to be done is there's a new content security policy directive called trusted types, and there's this my policy. It's a policy name. We will, again, get to that a little bit later. What happens when you have this content security policy header is you can no longer use strings, right? So assigning to inner HTML will actually be a type error. This becomes a programming error. This becomes something that you can monitor using your regular error collection services, let's say. But also you get a CSP violation, so if you're using CSP, it integrates well with all your other server-side collections. And of course, it is okay to use a trusted HTML object with the inner HTML sinks, because that object means that you, as the application author, explicitly trust the data within this object to be included into those sinks. It doesn't create a DOM XSS vulnerability according to your knowledge. But you can also go somewhere in between, right? Content security policy has this report-only mode that enables, let's say, progressive migration of your application or progressive hardening of your application. So you can specify that strings should still work, but I should at least know about them. So this assignment of a string will produce a CSP violation that gets collected later on, but your program will also continue just to work. So there's no breakage in this mode. Now, how do you create trusted types? We created those intermediate objects that give us very interesting benefits. These are called trusted type policies. So in order to use policies, you first have to create them, right? So there's a trusted types property on a window, and you call its create policy function. You give every policy a name. In this particular case, it's my policy. And then you specify rules. So for example, this particular policy, whenever I intend to create a trusted HTML object of it, using it, my custom sanitizer function should be called. And that explicitly says that an object created through this policy will have the data sanitized according to my rules, according to my application-specific custom, perhaps security review, most likely security reviewed rules. And then after creating this policy, it's just a JavaScript variable, right? So you can just use it. So I call, in the second snippet, a create HTML function with some input value, and what I get back is a trusted HTML object that I can safely use with the DOM. Now, as you can see on the bottom, what happens in the content security policy header is I explicitly whitelisted my policy. So it is okay, what I'm saying through this header is that it is okay for my application to use or create once a policy that is called my policy. And it is okay for my application to also use this other policy called my other policy, but it is not okay to create a policy that is named otherwise. And it is also a violation if you create a policy with a duplicate name. So with that, we get a control of how, optional control, because you're not even forced to use the content security policy header. You have a control of how many and which policies get created for your application. And through those policies, you can enforce rules on how the conversion of strings to types, to trusted types work. So this is the whitelist that I was talking to you about. And again, there's no possibility of having a duplicate policy name such that by mistake, you might create a policy that has different rules than the ones that you, for example, have reviewed for security. But policies are also just JavaScript objects after creation. So we can lock them down, lock access to them in the regular ways. You can lock them within a module and just not export them, so they would only be available from within a single module. You can put them inside a local function variable or a private class field. It's up to you. It allows you to compose the policies or expose the policies to only selected parts of your code, and only this code will actually have even the capability of introducing a DOM XSS, provided that the policy doesn't actually sanitize the data correctly, right? So all the code that doesn't have access to the policy cannot potentially cause an XSS in your application, at least the DOM XSS. But of course, this is very good for the code that you control, right? Because you can rewrite it to use the trusted types API. But what happens if you encounter a code that's something legacy, something third party, something that you can't really easily can change or are willing to change? Well, we have a concept called a default policy. And the default policy is nothing very special. It's just a policy with a name default, and you also have to allow it explicitly in the header if you're opting into this solution. But this policy is special in a way that it's being called implicitly. So all your places in your code that continue to use strings with those dangerous functions will get passed through this policy. And this policy can have arbitrary rules. So in this particular example, I want my application to continue working. So it's OK to create HTML or to write strings, arbitrary strings to inner HTML or other HTML things. But I want to know, right? So in this particular case, I just console log. But you might imagine I probably want to report it to some server, to some collection to get it reviewed, essentially. Or maybe I want to do some sanitization as a last effort. So this is the concept of a default policy. Now let's see this actual API in action. So yeah, I'm just trying to zoom in such that you can see the code. All right, so I took a look at the Cloud Player application. It's just some application that uses SoundCloud, YouTube, Mixcloud integrations in order to allow you to search for videos and just play them. It's a fairly reasonably sized application, right? And the way I wanted to demonstrate how to migrate this simple application to trusted types is like this. This application is built on top of the Angular framework. And Angular is a little bit special in terms of frameworks, because actually what they do is they have a concept of HTML or data sanitization in general. So whenever you interpolate user data into Angular templates, the data gets sanitized. And the sanitization is actually pretty decent. So I would argue that it is OK for my application to trust Angular doing its job in the data sanitization, right? So, and this is exactly what I'm doing. I forked a little bit the Angular platform browser framework, and simply, it's like a 100-line change of code, simply saying that whenever the data is being interpolated by Angular itself, after sanitization, then I just apply Angular-specific policy within the Angular code base. And later on, I simply have a content security policy header here that allows this policy name. This is something that I just use in the Angular source code, right? I allow this policy name to be applied. So as long as this application only uses Angular to interpolate data into the DOM, this should be fine. There should be no application side changes more than that required. So I'm just pointing this application to my fork of Angular platform browser, and it should all work. Now let's see if this actually happens. Let me zoom in a little bit. Yeah. Well, something broke. What broke is actually this application also happens to use jQuery. And jQuery has this nasty feature that, jQuery has this nasty feature of actually writing strings to DOM to do some feature testing. It's a very legacy way of asserting that the DOM works in a certain way, right? So what we can do about it is we can enable the default policy. And let's look at what this default policy actually does. Sorry. So as you can see in this particular module, I'm making sure, first I'm trying to make sure that the trusted type API is actually available in the browser. And then I create a default policy. And this default policy has certain rules. Let's go from the bottom maybe. First of all, I don't want it to ever allow for a trusted script, which is a programmatic way of saying I don't want eval in my code. Second of all, whenever a URL is being created, I'm just trying to make sure that it's not a JavaScript URL or nothing with those special protocol handlers like Chrome extension, intent on Android, and others, right? So I just want this application to use HTTP URLs and HTTPS URLs. That's fine. Everything else will just throw a type error. For script URLs, well, obviously this application does use a few scripts. So I want, in particular, It uses some YouTube API that tries to load a script from something that looks like this, right? I reviewed it, it's okay, so I'm just allowing the script. Otherwise, I wanted to continue working, but I want to know about it, right? So I console error or something. And for create HTML, I just whitelist whatever jQuery does to the DOM. That obviously doesn't have XSS payload, so it should be fine. Excuse me. And this is the default policy of this application. So when we reload this actual application, as you can see, interesting. The application started loading, and everything seems to be working. So we can search for, say, a JavaScript video and try to play it. It all works. You can check the other functions. Everything seems to be working. So migration to trusted types seems to be fairly low-key here. But what's happening here, right? I have this console error called please refactor script URL. And it's obviously loading analytics, and it's loading analytics in a way that I wasn't expecting. It's not using the Angular interpolation. But the security rules are now just part of our program, so we can just debug them. So I know for sure this is happening in the default policy, so let me set up a breakpoint and just reload and see where is this thing coming from. And this is coming from something called Google Analytics something model.ts, right? And indeed, this model is creating a script element and later on just using a string that I wasn't aware of. The application doesn't know yet that this is actually not user-controlled value, so it cannot tell for sure that this is safe, so I get this error. But we can change it, right? And thankfully, the Trusted Types API is based on types, meaning that we can write rules in our linters, in our code checkers, fairly early to warn you that you're probably doing something that might be risky or might break at runtime. And this is exactly what is happening here, right? So you get a squiggly line saying, this resource URL assignment from strings might result in script execution, so please use some kind of trusted type policy here, right? And we actually can propose even a fix. So we're proposing a fix like that. It will use this function that is imported from another module, and this another module will use a policy internally to do something. Now, how is that thing secure? It's thanks to the types. So this particular function only accepts string literals, meaning that I can surely use this one, and that's okay, but I cannot ever do something like this. Because this becomes then a compiler error, because this one is not a string literal without any interpolation there, right? So you cannot even compile an application that behaves insecurely. Of course, this requires not just the Trusted Types API, but some kind of integration in your IDE and integration with your linter, but Trusted Types at least allow you to write such rules where previously, when it was only based on strings, you didn't even have such a possibility. So if you can see, after actually compiling the application, this particular function should never be called. And you should be good to go, right? So what I'm getting actually from this policy is you're a good programmer and you're loading scripts from something, right? This is from the implementation of the policy that accepted only literal values. So this is how the API looks like. What are the benefits? First of all, for security, we like to talk about the attack surface a lot. So this approach significantly, by orders of magnitude, reduces the security surface for DOM XSS. Because previously, any potential line of code could introduce a DOM XSS because window is a global object, document is always accessible from there. It is possible to call inner HTML, all those other 60 functions in a way that is easily inspectable or even not. Like through RIXSS, for example, it's possible to have a code that doesn't immediately look like it's writing something to the sink, but it actually might. Here, only the parts of your code that have access to the policy and that policy doesn't sanitize the data in a correct way, only these parts of code can introduce DOM XSS. Everything else you can completely ignore, in terms of DOM XSS security at least. So it allows you to isolate those security-sensitive parts of your program from the rest of your application. And it does follow that if you have a list of policies that were security reviewed or were written, with care, you have no DOM XSS in your application, period. Because it doesn't matter what kind of data goes through those policies. If they are sanitizing it correctly, there's no possibility for your application to have the DOM XSS. It doesn't matter how many dependencies you're using. It doesn't matter if you have reviewed them. It doesn't even matter if you've looked at them a single time. You will not have DOM XSS. And because this is a typed API, you can introduce, write, or integrate security rules very early. It's not like the previous instances of the content security policy that will only tell you you're doing something risky or wrong or not compliant with the policy only when you actually deploy the application. Here, we can actually have security rules violations, or you get early feedback when you're actually writing the code, which I think is a pretty good advantage here. How does it work in practice? Because we've been using this API for quite some time. It turns out that you only need to create the policies in a few trusted components that necessarily need to interpolate into the DOM some data, and those tend to be the frameworks, of course, at least the view layer of the frameworks, the templating engines, the ones that were client-side, or some security-sensitive code like code loaders or HTML sanitizers like DOM Purify. And it tends to be easy, because we did some experimentation, to add the support for trusted types in a secure way to the frameworks. There's a link to the sample patch for Angular that I created. Of course, it's not merged yet because the API itself is not in final stage. And the code size is negligible. Actually, due to the shape of the API, we can introduce something called tinyfill. It's the smallest version of the polyfill that only polyfills the most crucial part of the API, and it's 66 bytes. That's all that you need to have for trusted types to work in a browser that's not even aware that this API exists. For regular applications, so far, our integrations were around 300 bytes. So that's pretty good. And we think that porting, especially the modern applications, the ones that are built on top of modern frameworks especially, and maybe have some additional dependencies that call the DOM in the old-fashioned way, you will have to use the default policy for those or some other means, but it is relatively easy. We're pretty happy with the results, and we're already doing that for Google applications. We have some pilots for most of our core applications, actually, and it works surprisingly well. The project is under active development, and as any security feature, I think it's crucial to actually ask the developers, not the security folks, of whether this makes sense, whether it's a good idea, or how to maybe change it to make it better. And that's why I'm here. I'm here to listen to your feedback, for you to ask me questions, for me to ask you questions, to talk about the practical implications of this API and how you could integrate it, what good ideas can you build on top of this API and whatnot. This API is supported in Chromium browsers since a couple of versions already. It's behind the origin trial, so you either have to use a command line flag or participate in the origin trial to get the support of this API, but we do intend to have it in the mainline Chrome, possibly Q4. There's a discussion group, there's a specification draft, because obviously this needs to be part of the whole W3C HTML spec. We have polyfills for other browsers, there's an extensive documentation, and we are right now in the stage of working with the external integrations of this API through the framework, such that as a JavaScript developer, you get the trusted type support for free. What you need to do is just use one of the modern frameworks, and they do the proper job of using the API. Right? So for example, if you know DOM Purify, the HTML sanitizer, I think the most popular one out there, it already gives you a trusted HTML object if your browser supports or your runtime environment supports trusted types. And we will work with the modern JavaScript frameworks to merge trusted type support with them. We've worked with TypeScript type definitions, so you can start using the API in your IDE if you're working on TypeScript. And we are working on more projects that use the trusted type primitives to build something that gives you actual security. So like a secure way of building HTML programmatically, or a secure way of sanitizing HTML and whatnot. This is coming soon to GitHub. So I think for the first time since 15 years, DOM XSS has 15 years, we actually have a chance of trying to address this problem and eradicate it from the web applications out there comprehensively. It's not even our first shot at this, but this time it feels right, at least looking at it from the security perspective. So if you get a chance later today or tomorrow when you get back home, just go to this link, try trusted types, tell us what you think, and let's stop DOM XSS together. Thank you.
Thank you, Chris.